In this video, I'll be helping you with the ALEKS problem type called partial fraction decomposition with an irreducible quadratic factor. To find the partial fraction decomposition, we first have to make sure that this denominator is factored as much as possible. And here it is that x squared plus 4 can't be factored any further. So my partial fractions will have 1 over x plus 2. And then the other fraction will be over x squared plus 4. And our numerators for partial fraction decomposition are 1 degree less than the denominators. So I'll have just a constant over x plus 2, but I'll need a bx plus c for this second fraction since it has to be 1 degree less than that second degree denominator. Now that we have the form, as before, we can multiply both sides by the lowest common denominator, which is that original denominator, in order to cancel all of these fractions. So each term on the left and right gets multiplied by x plus 2, x squared plus 4. And this allows us to cancel that denominator on the left-hand side and have just 2x squared minus 5x plus 6. On the right-hand side, first the x plus 2's cancel, leaving a times x squared plus 4. And then for that second fraction, the x squared plus 4's cancel, leaving bx plus c times x plus 2. From here, we have canceled all of those denominators, and we can start to solve for a, b, and c by first looking to see if there are any critical values for x that we can substitute in and cancel out any of these terms. And here I can see that on the right-hand side, if I choose x equals -2, I can cancel out this entire term because this portion will go to 0. So substituting in x equals -2 on both the left-hand side and the right-hand side gives me that 2 times -2 squared minus 5 times -2 plus 6 equals, on the right-hand side, replacing x with -2, I would have -2 squared plus 4 inside the parentheses, and then everything here goes to 0 since -2 plus 2 is 0. Continuing to simplify, on the left, we have 2 times -2 squared is 4. This would be a plus 10 plus 6 equals a times -2 squared is 4 plus 4. The left-hand side gives us 24 equals 8a. So a is 3. We found our first unknown. A is 3. I now just need to find b and c. If I substitute this a back in, I can rewrite this equation now with the known value of a. That would give us a 2x squared minus 5x plus 6 equals a is 3 times x squared plus 4 plus bx plus c times x plus 2. From here, all of our unknowns are in this piece, the b and the c. So I'm going to simplify as much as possible, first by distributing that 3 to be 3x squared plus 12. On the right-hand side, I still have the 2x squared minus 5x plus 6. And I can continue to isolate for my unknown variables here by subtracting the 3x squared over to the other side and subtracting the 12 over to the other side. Combining like terms, I now have a negative x squared minus 5x minus 6 equals, on the right-hand side, I can now do this multiplication. Bx times x is bx squared. Bx times 2, a 2bx. C times x, a plus cx. And c times 2, a 2c. I now have a quadratic on the left and the quadratic on the right. Looking at those coefficients, the x squared coefficients must be equal. So -1 equals b. We found our b value. And then the constants on the left minus 6, and the only constant on the right, 2c, must also be equal. So c equals a negative 3. We have found a, b, and c, 3, negative 1, and negative 3. Looking back at our original partial fraction, a we now know is 3, b is negative 1, and c is a minus 3. This would be our partial fraction decomposition.